what's going on. I just wanted to understand like how it's laid out. So the top line is the packets being sent from Google, for instance. Let's say Google servers is sending you a video, and then the middle line is the buffer on the client side receiving the packets, and then the third one is the actual playback.
So, like, why do network administrators ban UDP ports? UDP. Understand?
Well, it's not the network administrator picking UDP, it's the application.
Oh, I mean, just like, why do network administrators usually like ban UDP?
Well, they can,
Yeah. Thanks.
why did network administrators ban UDP?
They ban UDP? Well, it's not necessarily banned. I mean, it's,
I have heard of that.
well, it depends. It really depends on like what you mean by where it's where it's implemented at. Like if it's for something that's like sensitive, I guess, then yes. But if it's just for any like ordinary type of business or whatever, you're not going to really see that. But we're not like, but like we didn't really kind of come across anything like that. If that kind of answers your question.
The remote procedure call, you were talking about the actual pointers. And are we talking about the actual pointers in the program itself?
Yes.
So basically, okay. So that, yeah, that's yeah.
With your example, would there be, like, with how there's different gaps between all of these numbers, would there be any way to better control the time between each one so that there's more of a regular interval rather than it just being kind of that random like it seems to be?
So for the program, it is set to random. So it's totally likely that every single one of these is sent to received at the very next step. But as Jitter was talking about, due to the time delay, even if they were sent at regular intervals, because one packet might take longer than the previous, and that's the reason that there is a gap. But it is with a perfect network where you've got the best speed, there'd be no need for jitter control because jitter would be the delay. In a perfect network, there'd be no delay.
It's also important to note that I guess more recently you have, like, you're getting a lot more information in, well, using video as an example, you're probably going to get it in quicker than you're going to play it. So you just have a huge amount of video waiting to be played. And I guess using YouTube as an example again, like the gray bar, that's all the video that's been sent to you already. That, I mean, that's why you don't see it as much, and I guess it's less of a problem than it used to be. I don't know if that helps specify anything. In the back?
So when you add more flow, the number of flows increase. There's a minimum bandwidth that is allocated to each flow. How is that managed at the TCP level? Is there like who says this is the minimum bandwidth allowed, and how is that done on the TCP level?
You're asking who clarifies the minimum bandwidth?
Yeah.
I don't necessarily know if there's a minimum bandwidth required for anything, because I don't know how that could be enforced in any way.
What do you mean by, are you talking about for jitter, or are you talking about just in general for congestion?
In general.
In general for congestion? Well, I mean, if you're talking about, like, there is a set, like, depending on what you're using it for, there is a maximum set as that formula. As I mentioned in the formula of power is equal to load over delay, that your power is essentially the maximum potential that you can push. I guess to answer your question is the maximum amount for bandwidth per se in a given scenario. But for minimum, I mean, there's not really any sort of like bare minimum set. I mean, you could be sending nothing at all, and yeah, that would be sufficient for whatever. So
So for
like you said there's like a delay or like a missed packet, like the video kind of like what does it do again? Is like
It'll kind of like kind of glitch out, maybe glitch a little bit.
like we're at the point like we're not able like to notice that as much, right? Because like I know like sometimes we're at YouTube, so like what my question is like, are we able to like notice that as much anymore? Because I know like when we're playing videos, like and you see that bar like you were saying like it'll like be right at the point where like I'm loading up at like the same time it is like, but I'm not able to like notice if I'm missing packets. You know what I'm saying?
Yeah. Well, I mean, it's kind of like it all depends on your bandwidth for your network. If it's low to the point where you can definitely see a disruption of packets being sent, then yes, it's easy to see. But for most modern networks, you don't usually see that kind of skip in frame or frame drop or whatever. It's just kind of the nature of it all. Right. So.
I will say YouTube uses RTCP very intelligently because you were talking about how it'll load up to a certain point, but your video will play back, and then the buffered amount and your playback will be right beside each other for a very long time. That's because I know YouTube specifically just because I read about it, but they take the data and they see that the amount of bandwidth you have is very regular, so we're just going to send you this amount so it doesn't bother you at all, but we don't have the potential to waste bandwidth if you close the video, because that's sort of a loss on them if they send you the whole video in advance and you don't necessarily watch the whole thing. So that's just an example of them using RTCP really intelligently.
How much does congestion contribute to our campus's slow Wi-Fi?
Well, yeah, I'd say probably quite a bit. But you got to understand, there's a lot of people that are on the network at one time, and so it kind of has to compensate for that. If like I mentioned in that AI with additive and increase, multiplicative decrease, basically you want to find that fine line to where it won't be so crappy. It just depends on how you implement the control flow. So if you do it poorly, then you're going to get crappy service. But if it's too well thought out, you could actually cause a degradation in the quality of your packets.
So if I want client and server on one machine, and then pass some data between each other by using UDP, is there any packet loss?
I would assume no, because it's on the same machine, but something could happen bad in your computer. But I doubt it. It'd be a lot less likely than if you did it over the internet. Does that answer your question?
I mean, server and then same machine, server and a virtual machine?
Yes. No, it's just not virtual machine. It could be just one machine, and I just can run server and the client rights without needing any virtual things. So then I just want to send those things with some packets with each other. Since it's on one machine, I'm not sure there is any
It would depend on how the programs route the packets. If they routed them internally inside the machine, then there probably wouldn't be any. But if say it bounced it off a third-party server and then sent it back, or bounced it off your router, maybe there would probably be some packet loss in there, just because I'm assuming Wi-Fi. Wi-Fi has a 10% average packet loss rate.
For what purpose? Does local machine needs to send some kind of request in order to find local clients?
Well, I mean, are you you're sending it to the same machine, right?
Yep.
So you could use the loopback address and just literally keep it within the machine without having to send it out at all.
Yeah.
And I don't think that would contribute to any packet loss.
Are you trying to see if it's more efficient to use UDP rather than TCP? Because you're not doing the three-way handshake with yourself? Is that?
No, I just wanted to know, is it any packet loss or not? Just
Probably not, but that depends on your computer, I think.
Well, I mean, if you're doing it to your computer, it's on your machine. So you're not necessarily going to have a loss of any packets because it's directly there. Because that's just the functionality. That's where the hard drive is your hard drive's going to do that for you. The network's not going to have anything to do with that. So, I mean, unless you are specifically sending it out, then yes, that's where you'll see that being implemented. But if it's like local to your machine itself, then no, you're not gonna, that's not even gonna really matter much at all. So, that answers your questions? Yep.
Any other questions? If not, let's applaud the presenters.
So we were only able to get 3 boxes of these because we kind of cleaned them out. So if you've already had a donut, then you can just get some candy. But we'll try to get as much as we can. If we run out of